In modern society, the rapid advancement of science and technology has brought about unprecedented changes. From simple boats that relied on human oars in ancient times to today's high-tech large ships, our sailing journey is particularly spectacular. And these modern ships operate with little to no human intervention. Just press the start button and the boat can be at sea for dozens of days. However, while much of the world relies on fuel power to propel ships, China has embarked on a different path. Traditional power sail technology, which was once eliminated, has begun to attract the attention of Chinese scientists. Even more strikingly, they also launched an innovative supertanker. This 300,000-ton, very large oil tanker uses a sail power system and can travel on the sea relying only on wind power. This design is a bold experiment because it breaks through 100 years of traditional technology. So, how does China use sails to drive 300,000-ton, very large oil tankers to sail? Will this technology disrupt the entire industry in the future? If you like our video content, please click to subscribe to my YouTube channel so that you can receive all our latest video content. Now, let's get into today's topic. Currently, more than 130 countries and regions around the world have set carbon neutrality goals. These countries and regions hope that mankind can jointly respond to climate change, improve urban air quality, and reduce threats to human health. In the process of achieving this ambitious goal, the land transportation and energy industries have made significant progress, especially in the field of renewable energy. Data show that from 2010 to 2020, the global installed capacity of wind and solar energy has achieved rapid growth, increasing from 120 million kilowatts to more than 700 million kilowatts, a growth rate of nearly 5 times. However, the situation in the maritime domain is very different. According to statistics, about 50,000 merchant ships sail in the sea every day around the world. Pollutants such as sulfur dioxide and nitrogen oxides emitted by these ships not only cause serious damage to the marine ecosystem, but also greatly affect the air quality in coastal areas. According to data from the International Maritime Organization, carbon dioxide emissions from global merchant ships account for 3% of total emissions, and this proportion is expected to increase to 17% by 2050. While vessels using LNG as fuel can reduce these emissions, adoption of such vessels remains low globally. On the other hand, if oil or other chemicals leak during maritime transportation, the oil pollution will cover the ocean surface, hinder oxygen exchange, and pose a fatal threat to marine life. The 2002 Prestige oil tanker accident is a typical case. The accident released 77,000 tons of heavy oil and seriously polluted the northern coast of Spain. In order to cope with this challenge, the International Maritime Organization formulated new regulations in 2022, requiring the global shipping industry to reduce carbon dioxide emissions to half of 2008 levels by 2050. Therefore, countries around the world are actively looking for ways to reduce their dependence on fossil fuels, and China's efforts in this regard are particularly significant. As the world's largest electric vehicle market, the number of electric vehicles in China has increased from 1 million in 2018 to more than 5 million today. This growth is not only reflected in numbers, but also significantly improves the environmental situation. According to statistics, the popularity of electric vehicles has helped China reduce its total air pollutant emissions by about 1/3 in the past 5 years. The promotion of electric vehicles reduces the demand for oil and indirectly reduces the risk of oil leakage during maritime transportation, thereby effectively protecting the marine ecology. At present, China is not only promoting electric and new energy technologies in the field of land transportation, but also beginning to apply these technologies to large cargo ships at sea. As early as 2015, China launched a project called Sail Technology Demonstration Application Development. After 3 years of unremitting efforts, China's R&D team has not only mastered the R&D and manufacturing technology of airfoil sails, but has also reached the international leading level in design and application. By 2018, this technology demonstrated its strong practicality on the Kaili, the first very large oil tanker equipped with airfoil sails built in China. Imagine that each side of the ship is equipped with a huge metal sail with a height of 39.6 meters and a width of 14.78 meters, with a base diameter of 5.3 meters. It is not only visually spectacular, but also plays a significant role in improving navigation efficiency. In fact, after using sails, the Kaili reduced fuel consumption by up to 3%. Although this number may not seem like much in the shipping industry, this is already a huge improvement. Taking a conventional 300,000-ton oil tanker as an example, if the ship sails at sea at a speed of 15 knots per hour, its daily fuel consumption is between 70 and 90 tons. Therefore, a 3% fuel saving can reduce fuel consumption by 2.1 to 2.7 tons per day. This means that on an average sea journey from Asia to Europe, this technology alone can save tens or even hundreds of tons of fuel. More importantly, as a major country in the global trade of goods, China has tens of thousands of ships plying the global seas every year, and the carbon emissions generated cannot be underestimated. If wind-driven ships like the Kaili were widely used, it is estimated that each ship could save up to 2,918 tons of carbon dioxide emissions per year. This number is equivalent to the total emissions of 2,035 household cars for a year, or the equivalent of planting 160,000 trees. This not only helps reduce operating costs, but also plays an important role in promoting China's goal of carbon neutrality. But now, this method of sailing entirely dependent on wind power has caused some controversy. Some scholars from Japan and South Korea pointed out that such ships will not be able to continue sailing when there is insufficient wind. It is estimated that about 10% of the world's oceans experience long periods of calm winds. This may not only cause delays in cargo transportation, but in extreme cases, it may also affect the supply of food and water on board, posing challenges to the lives of crew members. So what is the reality? At present, China's Kaili, as the first ship to apply sail technology, has only taken one step on the journey of technological innovation. But any new technology will have some flaws and challenges in the early stages. Obviously, the Kaili also faces some problems raised by Japanese and Korean scholars. But it's worth emphasizing that these problems are not without solutions. China can improve its wind-catching efficiency by optimizing the design of the sail, so that the Kaili can maintain a certain sailing capability even under weak wind conditions. In addition, combined with modern navigation technology and weather forecasts, routes can be planned more accurately and effectively avoid windless areas, thereby reducing delays caused by insufficient wind. Once these technical issues are resolved, I think the huge potential of wind boats will be fully realized. In fact, if this kind of wind ship can reduce fuel consumption and carbon dioxide emissions by at least 20%. Given that many countries currently face huge challenges in achieving zero carbon or carbon-neutral climate goals, China's wind ship technology undoubtedly provides a practical solution for the world. As this technology continues to be improved and popularized, China is expected to occupy an important position in the international shipping market and use this innovative technology to bring considerable foreign exchange earnings. It is worth noting that in the field of shipbuilding manufacturing, although Japan and South Korea have long been important competitors, in the past 5 years, China's ship exports have achieved continuous growth, and their market share has increased year by year. Surpassing Japan and South Korea have become the world's leading countries in shipbuilding. Facing doubts and challenges from Japanese and Korean scholars, if China can accept these opinions with an open mind and regard them as a driving force for technological progress, then these challenges will allow China's shipbuilding industry to achieve greater success in the global market. To not miss out on our future projects and news updates, please make sure you subscribe to our channel and turn on notifications. We will continue to provide you with more exciting and interesting content.